In applications, it is sometimes necessary to connect angular speed, measured in units like radians per second, to linear speed, measured in units like feet per second. The connection is usually provided by one of the arc length formulas or by a conversion factor that equates 1 radian of angular measure to 1 radius of arc length. Linear speed is the speed of an object as it moves along a straight line or a curved path. It represents the rate at which an object covers distance in a certain direction and is typically measured in distance units per unit of time. Angular speed refers to the rate at which an object rotates or revolves around a specific point or axis. It is typically measured in radians per unit of time. Angular speed provides information about how fast an object is rotating or moving along a circular path. Today, we will learn how to apply what we studied about radians in the previous lesson through the following example. Jin's bicycle wheels are 28 inches, for high gear the pedal sprocket is 8 inches, and the wheel sprocket is 4 inches, in diameter. If he is pedaling at a rate of 1 revolution per second, find the speed of the bicycle. Looking at the given conditions, the pedal completes 1 revolution per second. If we try to calculate the length of the pedal sprocket's arc, we have S equals radius times theta. This is 4 inches times 2 pi radians, which equals 8 pi inches radians per revolution. For the wheel sprocket's arc length, we have S equals radius times theta. Since the two sprockets are connected by a chain, and the wheel sprocket rotates the same distance as the pedal sprocket for each revolution, we have 8 pi inches radians equals 2 inches times theta. Therefore, the angle of rotation for the wheel sprocket is 8 pi inches radians per 2 inches. It becomes 4 pi radians. This relationship can actually be intuitively understood without going through the calculation. The diameter of the pedal sprocket is twice the diameter of the wheel sprocket, so for every 1 revolution of the pedal sprocket, the wheel sprocket completes 2 revolutions. However, for the purpose of this lesson, we've gone through a slightly more complex calculation to practice what we've learned about radians. Now, let's proceed to find the arc length for the wheel's rotation. S equals radius times theta. So, it's 14 inches times 4 pi radians, which equals 56 pi inches. Now let's revisit the problem we need to solve. Since the wheel moves 56 pi inches per second, we need to multiply it by a unit conversion factor of 1 foot per 12 inches. Simplifying this, we get approximately 14 pi over 3 feet per second. This is a speed of about 14.66 feet per second. Now, let's convert this speed to mph. We need to multiply by the unit conversion factor of 3,600 seconds per 1 hour, and 1 mile per 5,280 feet. After cancelling out the units in the numerator and denominator, it becomes miles per hour. We arrive at a speed of approximately 9.996 miles per hour. See you next time.